join, but feel free to say hi where you're from on the chat. And we've got the Q&A open as well, so feel free to ask any questions on there as we go. So maybe while we're waiting, I'll just quickly, we'll do some quicker introductions. So I guess I'll start. So I'm Mark. I work in the product marketing engineering team at ClickHouse, and I am the person who's going to collect all your questions, say hi to you, and then ask the questions to our speakers. So I guess maybe Kritika, you can go first, and just a quick
Hey,
introduction.
I'm Kritika. Yeah, thanks, Mark. Hey, Kritika. If you can hear me, my name is Kritika. I'm on the product team. I lead the cloud product. We have an exciting lineup of feature announcements around the corner. So we're excited to do a deep dive on two of those. Zach?
Hi, everyone. My name's Zach. I work with Kritika on the product team, specifically focused on cloud and the cloud console. Yeah, very excited to show you what we've got cooking.
So so wow, there's loads of people writing now. I'm struggling to say hi to everyone, but yeah, good to have you all here. We've got loads of places covered. Zach, you've got a fan. You wrote Zach. We've got Mallorca, we've got Munich, Hong Kong, Croatia, Greece, Constantine, Uzbekistan, Mateus in Brazil. Wow, we've got loads of places covered. So we're going to be talking about two features in this session. So we're going to do bring your own cloud, and we're going to be talking about compute separation. So we've got a YouTube link as well in case you want to watch it afterwards. So I'll just paste that on here so you can all see it. That's where it is on YouTube. And
lots of excitement to see both Mark and Zach. I should be on more regularly.
Sorry?
Lots of excitement for Mark and Zach.
We have to join all the time now.
Mark,
right, should we? I reckon we give people enough time. Should we get started? You're going to share your screen, I think, Kritika. Cool, I can see it.
Perfect. Hey, thanks all for joining. As I mentioned early on, we have two big feature launches around the corner. So we decided we'll do a deep dive this time around. We did do a sneak preview the last time around. It was really a lot of good questions that came up. So we said, okay, let's do a deep dive and address them in a more closer setting. So starting with bring your own cloud. Yeah, I'm new to Zoom, which takes me a second to adjust. So starting with bring your own cloud, for those of you that are not familiar with this model of deployment, a quick intro. ClickHouse Cloud today is set up such that all the services that you launch is hosted within a ClickHouse managed account. With bring your own cloud, we are actually decoupling the data plane components, which is essentially storage, compute, all of these that interact with your data, and allowing for these to be hosted in the customer's account. The underlying architecture is the same, with this crucial difference of where the core components are deployed. Note that the UI, the web components that you see today with ClickHouse Cloud, essentially login, user management, service settings, starting, stopping your service, viewing system health, all of those are still hosted within the ClickHouse VPC. And for all practical purposes, we're ensuring no user managed data ever leaves the customer account. The offering is in private preview for AWS. We're working with a handful of design partners and getting ready for the beta launch in the coming weeks. I'll walk through the demo, but in terms of how it's set up today, once you log in, as you do today with ClickHouse Cloud, provided you have access to BYOC, you will be guided through a CloudFormation setup to give your account access for the data plane components to be deployed in your account. Once that's done, you can launch services as you do today with ClickHouse Cloud. The idea being once the service is set up, the only information that will leave your VPC is telemetry, metrics, anything that would be useful for us to know if your service is performing optimally. And with that, I'll get to the demo, but before that, just quickly talking through the reasoning on why we built this is really following the demand we saw from customers where they liked what they saw with ClickHouse Cloud, but hosting their data outside of an account that they do not control was a non-starter. So this is top of mind for customers or verticals that deal with PII or sensitive customer information, fintech, cybersecurity, healthcare, and several others. And this is not only a mandate, but also an important risk mitigation strategy for these customers. They want to get out of the business of managing ClickHouse, but cannot adopt ClickHouse Cloud in the current model, and hence the demand for BYOC. The next is total cost of ownership. This really benefits large-scale deployments, especially customers that have deeper discounts on infrastructure with their cloud provider. So they're able to run ClickHouse on a discounted infrastructure. In some cases, the discounts for our customers is a lot more steeper than ours. And they're able to co-locate apps in the same account, thereby reducing cost of egress, especially when you have large volumes of data that need to move across accounts. You can use peering, which further reduce the cost of having to move data in and out. And the other thing that comes up is for customers self-managing ClickHouse, they have a team of dedicated engineers that are responsible for managing ClickHouse, sizing, upgrades, all the operational aspects. And they want to be able to offload this. So this will essentially give their teams more time to focus on other business priorities. And the other advantages, the last two, are on the operational aspects where users want more flexibility with the instance type, ability to control upgrades. So in some sense, they get the best of both worlds, greater flexibility without compromising on control while reducing the operational overhead of managing ClickHouse. So the preview, as I mentioned before, is available in 10 regions. And please join the waitlist. I'll drop these links in the chat so you can get in touch with us and a team member will connect you. With that, let me stop sharing my slides and get to the demo setup. I'll have to exit out of here. So this is my Cloud Console login. So as you can see, I have several of these orgs already set up, some of them using ClickHouse Cloud in its hosted form. For the purposes of the demo today, I have a new BYOC demo org set up. This is what it will look once your org has been enabled for BYOC. So if you click here, it doesn't show up any of the cloud provider account. That's because you haven't linked it. So once you have all your AWS credentials, the account information, you click on this, and it redirects you to this CloudFormation stack, which is pre-configured. So this is pulling the YAML file from a shared resource. You acknowledge and create the stack. This will take roughly 40 minutes to complete. So we don't have that amount of time. So I have another org that I've already set up. So as you can see, this is a service running, and you can control the same set of things that you do today with ClickHouse Cloud, adjust the scaling operations. We also permit horizontal scaling in the setup. It's just blocked, requiring you to contact support, mainly because we want to make sure that you have capacity within the account to scale out as well as scale up and scale down. The same set of controls that you have with backups and endpoint security controls, all of those are available for you. So I can also create additional services in the same account, assuming it's in the same region. It can all be co-located in the same org. So yeah. Just going through the other options so you can see the service health. Let me switch to a running service. All of these are pretty much the same as, as you see today with ClickHouse Cloud. And let me switch back to the slideware. In terms of the prerequisites for this model of deployment, what we are asking customers to do is like really, this is tailored for deployments that are large scale. So we're expecting this to be anywhere over 700 gigs in memory utilization. That's the threshold that we've set. We ask that you dedicate a separate account for testing purposes, and you can make it work in the 10 regions that we support today. The next is fairly obvious. You accept the terms of use, and you're comfortable with the just-in-time access protocol that we have in place. This is specifically for days when there is an issue and a ClickHouse engineer wants elevated access to debug. We ask that you give us access for a period of time that you control, and we're able to go access and debug the issues. That could be access to AWS Kubernetes logs or the ClickHouse logs itself to ensure that we're able to remediate issues as they come up. We use CloudFormation today for setup. We'll be launching a Terraform provider soon. With that, just going over some of the questions that came up in our internal conversations with customers, as well as questions that came up in the last webinar. How will BYOC deployments be priced? If you're familiar with the ClickHouse Cloud model of pricing today, it is storage and compute. With BYOC, we are metering and charging users only on consumed memory, assuming that they meet the minimum threshold that I shared before. And the one question that comes up from a lot of self-managed customers is, do we have access to the cloud exclusive features such as shared merge tree, compute separation that Zach will talk in just a bit? And the answer is yes. That being said, there are a few features at this time that are restricted, mainly because it's additional work, and we have this on the roadmap to fast track. One is auto scaling. That being said, idling and manual scaling is still supported. ClickPipes is on the roadmap, and same is the case with SQL Console today because it is coupled with the control plane by virtue of the fact that a user executes a query, the control plane, it means that data leaves their VPC, which is why we disabled it for this model of deployment. But rest assured, you can query the same way as you do today with your IDE, dashboards, your favorite tool of choice. And last but not the least, this was actually the first and the most frequently asked feature for this model of deployment is peering. This is bidirectional as well as more cost-effective in comparison to private link. And yes, this model of deployment supports VPC peering. And in terms of what's next, we have the beta launch coming up in a few weeks. We will be targeting GA early next year. The expansion to Azure and GCP is where we would love your input. We're trying to decide between the two, which is more favored. We are seeing a lot more requests for Azure at this time, so it's likely that we will prioritize that over GCP. But rest assured, the plan is to have this model of deployment be available on all three CSPs. And the other one that comes up is support for additional regions. Like I said, we support the 10 regions that is supported for ClickHouse Cloud today, but the goal is to expand this region list and decouple the dependency. So you should be able to deploy in any region of your choice, regardless of ClickHouse Cloud's availability in that region. And CloudFormation, alternative Terraform, I think this was actually a mandate for a few companies that we spoke to. So that is something that we will tackle during the beta timeframe. And ensuring feature parity with ClickHouse Cloud, starting with auto scaling, ClickPipes, SQL Console, and Query API endpoints. But if anything else comes up, we'll ensure that there is feature parity between the two versions. With that, I'm going to drop some resources. Like I said, we have a waitlist page. We have the documentation in our public docs. And we also have the shared responsibility guidelines in our trust center. With this model of deployment, since we do not control the infrastructure, we ask that customers partner with us on implementing best practices, both on our side as well as on your end, to jointly ensure a secure and stable ClickHouse service. This includes IAM policy guidance, data security, how do you go about enforcing encryption controls, making sure that you implement network security best practices to prevent DDoS attacks, monitoring, data durability. We do periodic checks on our backups. Since this is something that you control, we ask that you do the same. And aspects of compliance as to how you follow and extend basically what we have with what you need to comply to, if it's PCI, HIPAA, anything else that this environment needs to be in compliance with. With that, I will pause. I know there were a few questions. GCP, yeah, thanks. Yeah, please do submit the request on the waitlist page. I'll drop the resources. Mark, were there any questions?
And then we've got one other, right? Do you support hybrid cloud was the last question.
Hybrid cloud, if this is a dual strategy where you have multiple cloud deployments or on-prem and cloud, that is not a model that we support today. But if you can send us the information on the contact me, we'll get in touch and we can discuss more. Will BYOC meet FedRAMP? That's a good question. So there are controls that we can work with you on, but essentially for compliance, this is on the side of the customer because we give you the binaries, but the environment itself needing to be compliant is shared responsibility between us and the customer itself. But please do send us your information and we'll be in touch. How is HIPAA compliance handled with BYOC? The way we have it set up today is isolation, ensuring that it is in an environment with restricted controls. Since we already know the protocol on how to set this up, we can work with you to deploy the same controls. And there was a question from Connor on how will the pricing model look like. This is, again, since it's in preview, we haven't published a public pricing page yet. Connor, if you're interested, please send us your information, the size of your deployment, and we'll get in touch and work with you on pricing. Can I choose the number of nodes? Yes, you can. So the CloudFormation stack is essentially setting up of the infrastructure when you launch your service. There is the set of controls, and of course, you want to horizontally scale. Log a support ticket will enable this for you as far as you have capacity in the account. You should be able to do that.
Then we had one more from Clem. How will shard migration actually work from an existing, I guess, not BYOC cluster to BYOC?
Yeah, that's a good question. We have been doing several of these migrations using remote secure. Yeah, the concept of sharding goes away. But yeah, please, our backup restore is an additional technique for us to do this migration. And okay, I'm just trying to scroll back and see if I missed any questions. But yeah, I'll hand it over to Zach and I can answer on the Q&A. Let me go on mute. Zach, over to you.
Hey everyone. So I want to kind of preview a forthcoming feature that we're super excited about and also give you guys a sneak peek bonus feature that we're working on in the Cloud Console as well. So with that, we're going to talk about compute separation, which is a highly requested feature in ClickHouse Cloud. In effect, what we're doing is kind of adding the ability to have multiple kind of isolated node groups that are connected to the same keeper cluster and kind of underlying S3 prefix. So in effect, kind of constituting an entire warehouse, right, with kind of isolated resources for readers, writers, etc. Each kind of group of resources can scale horizontally and vertically independently, and you can configure different resource groups to either have read-write privileges or read-only privileges based on your needs. Each resource group also gets its own set of discrete endpoints, meaning that you can kind of at query time kind of determine which resources you actually want to execute your queries against. Next slide, please. So key points here, like why exactly is this important? Number one is kind of compute isolation for different business units. Different kind of I guess, departments or teams within an organization may have varying kind of performance or cost requirements. Maybe they have latency SLAs for kind of downstream consumers, and each department or team can get its own group of resources such that they don't kind of they aren't affected by noisy neighbors, and each kind of team can budget their resources accordingly. Similarly, kind of isolation of reads and writes. Obviously, without resource isolation, if you have a really, really heavy reader write workload and it spikes, it may affect kind of other workloads that are running on the same cluster. With compute separation, this is kind of no longer an issue. You can have kind of read-only nodes that are principally in charge of kind of powering customer-facing applications. Meanwhile, a different set of writer nodes that are kind of principally responsible for actually writing data and performing merges in the background without consuming the same kind of resources. Additionally, like say you've got ad hoc workloads that you want to run occasionally that are relatively resource intensive, you can kind of configure specific node groups to scale to 0 when they're not in use and just spin them up whenever the need arises, thereby saving on cost. And finally, again, I think we alluded to this in the last slide, different horizontal and vertical scaling for different workloads. This is super important because kind of currently your ClickHouse Cloud cluster needs to have the size and shape kind of constituting the lowest common denominator between what resources are needed for your write workload, your read workload, or kind of any combination of workloads that you want to run. So for example, if you need kind of incredibly high concurrency and throughput for your kind of write workload, you need a lot of nodes. And if you've got really, really heavy analytical queries on the consumption side, you need really large nodes. Right now, the lowest common denominator then is many large nodes. In this kind of new paradigm with compute separation, that goes away. You can have one set of relatively small writer nodes, and then a smaller set of relatively kind of large reader nodes as well. So in effect, you can kind of fully right size your cluster to kind of meet your workload requirements. Next slide, please. And so, yeah, we've got the private preview underway. If you want to check out the documentation, it's live in this section in our cloud documentation called Compute Separation. And you can reach out to support if you want early access to this feature. It is incredibly exciting, and we're looking forward to rolling this out more broadly in the near future. Next slide, please. And finally, just one cool sneak peek we wanted to kind of give you. We've been working kind of behind the scenes on a dashboard / visualization layer directly in the Cloud Console. The kind of goal here isn't to replace or supplant any really high-powered kind of BI or visualization tools such as like Tableau or Metabase. Really, the goal here is just to provide you with a suite of visualization tooling that sits right on top of your ClickHouse Cloud clusters. And basically demonstrates exactly kind of how powerful ClickHouse Cloud can be without ever leaving the console. So with that, I'm going to actually give you guys a quick demo of both compute separation and dashboards. Let me share my screen. All right. So we can see here, this is the Cloud Console with kind of compute separation enabled. As you can see here, we've got 2 services, but there's something different about these services. They're kind of grouped together under this analytics primary moniker here. This is now called a warehouse, and both of these services represent resource groups that exist within this warehouse. So they're sharing the same keeper cluster and the same underlying S3 prefix. The tables are the same, and as you can see here, right, they've got different sizes and shapes. One is read and write, one is read only, and so we've kind of set that up such that you've got kind of a writer group here and then a reader group somewhere else. Obviously, they share the same CSP region, version, underlying kind of database password, etc. And we can do things like add a new service to this warehouse group. We won't do it right this very second, but say we wanted to say like ad hoc cluster. We could set this one to read only, give it like 2 replicas, and pin those at a really, really high kind of memory allocation. And we can set the idling time really aggressively, since this will be ad hoc. And now this new compute group is provisioning, but while it's going on, we'll go ahead and take a look at what's actually going on in our current resource groups here. So we've got analytics writers, and as you can see, the demo gods are not smiling upon us. All right, we'll come back to that. Alrighty, I don't know what the issue is here, but I guess we can kind of come back to this in a second, and we'll move on to dashboards. So here is kind of what we've been working on. In effect, basically dashboards constitute these objects. You can either have big stat objects, you can have charts, tables, rich text, and dividers, all that kind of stuff, and they're fully interactive. So each of these objects is powered by an underlying kind of saved query. You can see here, this one is called instance list, and here's like a preview of what that query actually looks like. It takes one parameter, in this case, seconds, and that is tied to a filter that we've got at the global level, and right now it's 86,400, which is 1 day. So this is showing all instances that have been active in the past 1 day. Moving on, we've got things like queries per second, and this is a parameterized query that in effect is actually taking not only seconds, but also rounding and a namespace, which is fed from this, this reference table here. As we can see, basically any parameter, so for example, namespace here can be sourced from any kind of reference object. So for example, from table 1, and then we selected field to link as selected row instance ns. And then again, seconds and rounding are both coming from kind of the global level. And the global level is kind of any sort of set of parameters that you want to configure and push down to all charts or objects consistently at the same time. So with all that in mind, obviously we can kind of click around, and as we kind of click, we pass in new parameters and rerun all of these queries underlying all of these charts beneath it. And of course, all of the charts are fully configurable. For example, if we wanted to kind of update things like the number of decimals, or kind of remove chart objects from the console, we can do so here. And we can do things like add a new chart. Let's say we want to go queries running. And I guess the demo gods really are not smiling upon us today. In any event, I guess we'll polish this up, and we will bring it back on the next cloud update fully working.
We got some questions anyway, so we'll go. Yeah, I guess we'll go from the earliest one, and then we'll come back down. So David asks, is there any performance penalty with compute storage separation? Because that's right from the beginning.
Is there any performance penalty for with
compute storage separation?
Storage? So just, I guess, taking this question at face value with compute storage separation versus compute separation, we do pay a small penalty for compute and storage separation, obviously, because all of your data is backed on object storage. So obviously there is a slight IO bottleneck that exists, when you're kind of pulling stuff out of S3 and putting it back into S3. But, kind of behind the scenes, we kind of handle this very intelligently. And we kind of leave a lot of data in various caches. So we've got a write-through cache and a read-through cache, and kind of various other caching mechanisms that we're using, such that, as you're kind of writing data into object storage and quickly querying it back out, we don't need to kind of push it and pull it, thereby kind of lessening the bottleneck. Really kind of the only real bottleneck is, again, that kind of object storage IO. For compute separation, you don't really pay performance penalty. In fact, kind of quite the opposite, right? Each set of nodes kind of operates semi-independently, and some nodes can be kind of instructed not to participate in background mutations and merges, such that they don't experience performance degradation when there's a burst in kind of write throughput at any given point in time. Any more questions?
Hopefully, yeah, there's another one from Mozen, hopefully. Can horizontal autoscaling be automated based on resource consumption, like how you do with Kubernetes horizontal pod autoscaling? I assume that's what HPA means.
Yes, this is kind of our eventual vision for horizontal scaling, is that really your cluster should be able to scale up and down vertically, or kind of in and out horizontally, based on kind of any set of kind of resource utilization parameters. At the time being, horizontal scaling is only kind of manually configurable, but this will change in the kind of mid to long term, as we kind of determine exactly under which scenarios we'd want to scale you vertically versus horizontally.
Cool. Then we've got a couple of people sympathizing with the demo gods. So I guess we probably are saying they've seen a similar error as you had. So maybe we'll chase that up for you and see what's going on. Next one, Andrew. Can we create more than one read-write service?
Yes, we can have more than one read-write service. You can have any arbitrary number of read-write services, read-only services, anything you like.
Cool. And the next one says, should have different console or dashboard for different services. I'm not sure if it's saying can you or do you, or yeah, should you have different console or dashboard for different services? Because that's basically
yes. Right now, each kind of service or compute resource right within a warehouse basically gets its own console instance and its own kind of dashboard area, etc. So you can kind of monitor all of your kind of resource utilization for each resource group independently of one another.
Okay, then not sure about this one. So does the cluster API let us drive horizontal scaling ourselves based on our own metrics?
Yes. So when we enable horizontal scaling for a given service, you not only get access to kind of configure the number of replicas via UI, you also get it via API. So for example, if you are consuming Prometheus metrics or other kind of heuristics about your cluster, and you want to kind of set up some programmatic trigger to scale it in or out accordingly, you can do so via API.
Okay, I'll go back up. Leah Trim. In a one database multi-tenancy setup, what would be the process to create a compute instance to give access to a tenant only for their own data?
In a one database okay, so if you wanted kind of full, I guess, tenant data isolation, you'd probably use some combination of compute separation just to kind of isolate resources, and then you would use some sort of access policy for specific database users that exist on your cluster, such that for example, if you've got database level namespace, right, and you've got tenant 1, tenant 2, you can kind of grant access only to tenant 1.star for the tenant 1 user, and 2.star for the tenant 2 user. I guess that's probably what this question's alluding to, but
yeah, you can tell us if it wasn't. Another one. What happens, or can you have two separate computes writing to the same table at the same time?
Yes, because it's still got one underlying kind of keeper cluster, right? So basically, all write operations that are occurring are still kind of being coordinated by this kind of centralized group of keeper nodes. So in effect, you can seamlessly write from different groups to the same table with no issue.
Okay, cool. I think that then partly answers Gustavo's question. Do read and write services share the table and database, or do each of them, or should each one have their own click pipe?
Let's say you've got different Kafka streams or Kafka topics, right, that you want to ingest into different places, and you want to use different resources to do so. Maybe you kind of provision click pipes on two different read and write services. However, there's kind of no requirement for this, right? If you basically just want to kind of pipe data into a table from a single topic, you can kind of set it up on any arbitrary read and write resource group within the warehouse.
Cool. Ruben asks, can you limit access to specific user groups for compute separated services that share the same primary service?
Yes, this is all coming in the immediate future. We're kind of working to overhaul our entire kind of RBAC layer in the Cloud Console. We'll have kind of service level kind of role groupings coming soon that will allow you to effectively turn off access, say, to the primary service in a warehouse, but give access, read-only access, for example, to a subset of compute groups that may exist within that warehouse. It will all be kind of granularly controllable, kind of at the service level or resource level.
Okay, next one from Luca. What's the minimum amount of nodes for, e.g., a new write cluster in a warehouse?
So I think kind of out of the gate, our primary restriction is that your primary service, so the first one that you spin up, needs to have at least 2 replicas. But any kind of subsequent service that you provision within the same warehouse can have as few as 1 replica and as many as you like. So in effect, you can with the exception of kind of the primary service for a given warehouse, you can select any horizontal scale from 1 up to, I think, 25.
Okay. Next one, Steve. I think this is just a general question, but correct me if I'm wrong. What reporting is available to understand runtime auto-scaling behavior, e.g. cluster size versus utilization over time?
Yeah, I think this actually comes back to kind of another thing that's very top of mind for us on the cloud team right now, which is kind of observability of your ClickHouse cloud clusters. Obviously our auto-scaling process is relatively opaque at present, and we're working to improve that. So the first step is going to be actually kind of just exposing, cluster resource utilization. Right now we expose allocation only, but we want to kind of start exposing resource utilization as well. So, at any given point in time, how much CPU and memory is each replica in your cluster consuming? And I think that, that will kind of start to, make it a little bit more clear when and kind of why we, conduct scaling operations. That being said, kind of just some, I guess, top level details. Currently for kind of CPU bound vertical auto scaling, when your total cluster CPU utilization exceeds, I think, 50 or 60%, we begin to scale you up. And when we see that you're kind of consuming less than, I think, 25%, we potentially begin to scale you down. Similarly, kind of for memory, I think it's actually more triggered by OOMs. So if you start running into out of memory exceptions on your cluster, that's a very solid signal that we potentially need to start adding additional kind of vertical size to your replicas. And similarly, if there isn't substantial kind of resource like memory utilization at any given point in time for let's say 30 minutes or an hour, it kind of depends on the look back, kind of depends on your how bursty your cluster is, but in effect, if you aren't consuming huge amounts of memory, we will scale you down to right size. This will all become a little bit more, I guess, discernible with some of the new observability functionality that we're building out in the Cloud Console.
Cool. All right, next one. Adam, is it possible to have powerful instance for read-write nodes and less powerful instances for read-only in compute separation?
Yes, exactly. This is, I guess, principally what we are aiming to accomplish with compute separation. So, either powerful instances for read write and less powerful for read only, or kind of vice versa, right? We'll support both. In some cases, right, your ingest workload may be incredibly resource intensive. Maybe it's also got a bunch of downstream, tables that are kind of chained via materialized views, and or there's kind of projections that need to be recalculated, during ingest. All of these things, may contribute to kind of like resource utilization, kind of for your ingest workload. But maybe your read workload is, relatively small. In that case, you can definitely kind of provision a very small or relatively small kind of read-only cluster that's reading that data back out.
Okay, cool. Connor, is there a limit to node groups, and can we host these groups on different clouds?
So I think that there is kind of a total replica limit for all, kind of for all node groups within a warehouse. I think currently that number sits around 30, but it will kind of increase as we, continually, stress test, different scenarios with multiple node groups. See how many kind of replicas we can support. The second part of the question, can we host these groups on different clouds? The answer is no, you cannot. And the reason is because each kind of set of node groups, still shares an underlying kind of S3 prefix, which obviously lives in one cloud's kind of object storage analog, and also a keeper cluster, which will also kind of be deployed in given CSP region. For that reason, like your warehouse that contains different compute groups needs to kind of adhere to kind of the same CSP and the same region. Those are kind of hard requirements.
By the way, Zach, I think Connor corrected and said a number of node groups, not the different clouds. That was what he meant to ask. So it wasn't a multi-region question or multi-cloud question.
It's like, can we get taller node memory?
Oh, no. Where he asked the
before
question,
that.
different groups on different clouds, he meant different groups, number of node groups. That's what he meant. So it wasn't being able to have the compute group in a different cloud. So we already covered that. So
yeah, any set of warehouses can you can deploy different warehouses in different CSPs and in different regions, and you can have kind of sub node groups within them.
Cool. And then we got, as you said, Andrew, can we get taller node memory than 240 gigabytes, and will the ClickHouse engine ever parallelize queries for actively to spread memory usage across them? Because that's not really related. Is that related to compute separation, or not really?
Well, kind of not really, but okay. We can still answer this one. I guess the first part of the question, can we get taller node memory than 240? Yes, contact support in various regions. In some CSPs, we can support 360, and in some cases even I think 480. So just reach out, and we're happy to kind of work with you on that. And will this ClickHouse engine ever parallelize queries for us to actively spread memory usage across nodes? The answer to this is yes as well. We're working on kind of parallel reading from replicas. Right now, you can kind of enable this, through a setting that you can pass in at query time. I think it's an experimental feature, so you'll have to kind of run it by us first. But the plan is to release this in GA and kind of make it available by default, such that when you execute any given query, it will kind of automatically break up the work and assign it to different nodes within your cluster. And then kind of on top of that, in the longer term as well, it's still early days, but eventually we're going to also introduce something called like stateless query offload, where there can be a pool of stateless ClickHouse servers in any given region, and on demand they can kind of attach and kind of complete various tasks to kind of boost your performance during query execution.
I think we've got one more from Peter. Do you have any estimations on how much of a performance gain you would get from having separate write and read replicas? I mean, I guess this is going to depend on the workload, but I guess you can invent a scenario.
Yeah, so I think you, I guess an estimation. Let's say we have a scenario where you have an incredibly kind of high throughput write workload, and because of, I guess, downstream, tables that are chained via materialized views, each time a record's inserted, it triggers, kind of the creation of records in, let's say, half a dozen other tables somewhere across your ClickHouse instance. In this case, you probably have a lot of merges running in the background at any given point in time. Your part count is probably relatively high, and ClickHouse needs to allocate a lot of compute resources to, kind of keep running merges and keep pushing that part count down as much as possible in order to kind of keep up with your ingest workload. Without compute separation, this would throttle your read performance, right? Because ClickHouse needs to allocate a certain amount of resources to kind of, just keep up with all of the writes that are going on. With compute separation, obviously, you can have a separate set of nodes that are not participating in any merges, not participating in any sort of ingest related work. So they don't pay a penalty in this scenario for kind of heavy writes.
Cool. I think. Oh, we got another question, just as I thought we'd done all of them. Mosen, is there a way to avoid exposing any API or endpoints externally and instead use VPC peering to share metrics with the ClickHouse console?
So is this, I'm trying to read this. So this is with share metrics with ClickHouse console. I'm assuming this question is for the health metrics.
I think that's a BYOC question, but for health metrics, probably.
Okay, yeah, there you go. Yes, it is supported. For BYOC, it is supported. We support peering. As for the health metrics itself, we right now assume that it's like non-customer metrics, so we haven't enforced some security, including private link support for that endpoint, but we can explore ways to support that pattern. Because
Cool.
the itself is pretty much abstracting away any customer information. It's mostly health metrics. So we didn't get a lot of pushback on enforcing control on that endpoint, but it's a valid feedback. We'll take it back to the team. Sorry, Mark, I spoke over you.
No, it's fine. Yeah, I was going to say, I guess we've. Thank you all so much for asking us so many questions. This has been. Zach's done a lot of talking. He's probably run out his voice now.
There is another question, actually. Is it possible to connect on-premise MinIO to ClickHouse Cloud? This pattern for the cloud hasn't emerged. We have had other deployments like on-prem self-managed that use MinIO. But if you can please post this question to us on the Contact Me, we will work with you on the use case that you're trying to set up this way. Right, last call. Was there another question that came in? Okay, thanks. It was just thanks. Okay.
Just finding the contact link again. I know you posted it, posted it up the top. Cool. Otherwise, yeah, thanks for all your questions and thanks for coming to watch. We've got another question now, Gustavo. Is it possible to make notifications of errors on ClickPipes?
Yes, this is coming very soon.
Cool. Otherwise, I think I think we'll call it a day there. So thanks everybody for coming to watch, and thanks Kritika and Zach for showing us these features. I guess the next one we'll probably do will be maybe the 2nd or 3rd week of January, but we haven't decided what the topic will be yet. But we'll let you know when we've decided. Otherwise, thanks everyone. We'll see you next time.